I'm still laughing after reading this riddle. How can you get into your home if there's a dangerous dog inside that doesn't know you and belongs to your wife's friend? So, I'll let you think about that. Pause the video if you want to think longer. How do you get into your home if there's a dangerous dog inside that doesn't know you and belongs to your wife's friend? Well, you go in through the door. That's how you get in. You go in through the door. So I thought that was funny. I don't know. I like it. And you probably don't because you didn't get it and you're all bitter now. Alright, so here's the deal. We have really one more test to teach you. We'll do the telescoping series in class. And I'm going to give you guys one more example, run through this, and then I'm going to have you do 3 on your own before you come to class to give you some practice with what you guys have just learned tonight. Okay, so the test number 8, the test for absolute convergence. This is just a summary with these nice little fluffy, pillowy, bubbly things here with shading behind them. If the series converges absolutely, then the series converges. Okay. If you test for absolute convergence and it diverges, then that alternating series test, if it converges, then you would say it converges conditionally. Okay. And if it fails still the alternating series test, then you would say that the series would diverge. Okay. So I'll gloss over this important note here. Might talk about that in class. But let's go ahead and take a look at the alternating series test. And basically, if it's an alternating series, it'll converge as long as these 2 conditions are met. Okay. If the absolute values decrease in value eventually, once they hit a certain point, as long as the next term is smaller in absolute value than the term just before it, then we would say that this first condition would be met. Okay, and we're going to do that down here. And then the limit of the nth term is 0. As long as these 2 conditions are met, the series converges if it's an alternating series. So you can't even use this if it's not an alternating series. So that's what this means. Alternating series all converge as long as this first condition and this second condition are met. Okay? And this is really useful. Like it says here, when you're testing the convergence at the endpoints of an interval. Okay? And so you'll need this test to test the endpoints for examples 13 and 14, which are 2 of the problems of the 3 that I'm going to have you guys do. In fact, let me just tell you right now. I'm going to have you do 13, 14, and 19. Do those on your own, and then I'll have a separate video that shows the solutions to those. But those, if you can do those 3 problems, then you have a good idea, good fundamental idea of what you're supposed to do in this section, and you could probably answer most of the FRQ problems that you'll see, and we'll go over those in class as well. Okay, so example number 16, we can see that it's an alternating series, but let's do this first. Let's just see if this series converges absolutely. Okay, and so we would test for absolute convergence by throwing out the minus signs and go from 1 to infinity, and we would say 1 over, and I don't like to write it as cube root of n, I'd rather write it as n to the 1/3. Well, this series, you should automatically be able to see that this series diverges, and you should also remember that the series diverges because, and you should be able to finish my sentence, this series diverges because it's a P series, and all you have to do is say P series P, I should say, equals 1/3, which is less than 1. Okay, so if the P is less than 1, the series diverges. And so let's test for, so that's the first thing, we're going to test for absolute convergence. Well, it doesn't converge. This series does not converge absolutely, but it still might converge. Okay, and I just remembered, I get this question a lot. Well, Mr. Hawks, does the series converge if it converges conditionally? Well, yes. If a series converges conditionally, it converges. And if you're being asked, does the series converge? Well, yes. You would say, yes, the series converges. You only have to worry about the conditionally part if you're being asked, well, how does it converge? Does it converge conditionally or absolutely? That's when you have to worry about it. But if a series converges conditionally, it converges, period. Okay? So we're going to test again for conditional convergence. Test for conditional convergence. Okay? It'd be nice if my words just kind of rang in your heads as you're getting ready for the AP exam. You just can't even get rid of my voice in your head after watching the videos for so long. And then on the AP exam, you just hear my voice saying these things, and that'd be kind of cool. So we test for conditional convergence. The alternating series test. Alternating series test. Right? So condition number 1. Well, let's see here. Condition number 1, a sub n is greater than a sub n plus 1. Is that true? A sub n is greater than a sub n plus 1. And keep in mind that a sub n, then a sub n plus 1, then a sub n plus 2, and so forth. So in other words, this term a sub n is the term just before the a sub n plus 1. Okay? So they go in order. You know, you have a sub n minus 1, and so this is all you have to say to say, well, okay, the first condition was met. Well, how do we know that? Well, let's take a look at the series, and let's move this right on up here. If n is 1, the first term is positive, and we have 1. Okay, and then we have minus 1 over 2 to the 1/3 plus 1 over 3 to the 1/3 minus 1 over, that's a minus sign there, minus 1 over 4 to the 1/3. Well, the denominators are getting bigger, right? Okay, so if we're just looking at the absolute value of these numbers, the denominators are getting bigger. They're all being raised to the 1/3, so really just looking at the 2, 3, 4, 5, 6, 7. If the denominator of a fraction is getting bigger, it means the fraction is getting smaller. So that's what we want. And then we say that a sub n is greater than a sub n plus 1. That's all you have to say. Okay, and then for the second part, what's the limit of the nth term? Well, the limit as n approaches infinity of the nth term, which would be 1 over cube root of n, we don't worry about the negative part, just the absolute value of this one. A sub n is the part that doesn't have that minus 1 or the n plus 1 part. Okay, so as n gets bigger and bigger and bigger, this limit is 0. And so, sorry about the focus there. That's a little bit better. So if the limit is 0, we say, therefore, the series from 1 to infinity of negative 1 to the n plus 1 over n to the 1/3 converges. We say it converges, period. Okay? And it showed it's convergent. We say, therefore, it converges. So we're done. If you are ever asked how does it converge, you would say conditionally. Okay, so that's 8, almost 9 minutes actually. And again, what I want you to do now is do numbers 13, 14, and 19 before you come to class. Check the solutions in the next video, and I will see you in class.